Hello everyone, my name is Devi Prasad Dotto and I am going to teach you about a new topic, a new experiment that is in your syllabus and which is nothing other than but the cathode ray experiment which was done back in 1897, which is nearly 120, more than 20 years. So it was done by a British scientist called J.J. Thomson. His full name was Joseph John Thomson, as you can see in my first slide. So let's start. So the first thing to know about the cathode ray experiment is what is a cathode. So if you want to know a cathode, just think about a battery and that is connected with a bulb. Okay, as you can see in this diagram over here. So in a battery, there are two things that actually generates electricity that we can tell. One is the cathode and one is the anode, which are joined by this blue structure that you can see, which is labeled as electrolytes. So electrolyte are responsible for the electrons that are jumping from the cathode to anode. So cathode, from cathode to anode, the electrons we can say are swimming towards the anode and completing the cycle. You can see the arrows are given. So it is completing the cycle, and in the cycle there is a bulb is present, which is being blown by the action of those electrons flowing. So just to remind, just to summarize, we can tell that as you can see in my a slide, that a place on a battery or electrical device where electric current actually leaves, that place is called as cathode. Every battery or electrical circuit have a part where electrons are leaving. As you can see here, this negative sign circles or spheres are drawn, which are actually the electrons which are leaving. So this part we call something as the cathode. And so from the cathode to anode, electrons actually swim through the electrolyte that is present over here. Understood? So if we want to move now, we are going to learn about something called cathode rays. Okay, so what are cathode rays? We have learned about cathode. Now to learn something called cathode rays, as this experiment is about cathode rays, right? So cathode rays are, so we have told that from cathode to anode, electrons actually travel, as you can see. But how they travel? Suppose we just replace the electrolyte by something called a vacuum. Now, what is a vacuum? That is very important. As we can see in the slide over here, if in place of the electrolyte that was a liquid, there is nothing or vacuum. So we are sucking out everything from the container we are using. So here we are using this container type thing. You can see this is a nothing but a glass tube, and here there is a vacuum pump, it is written, right? That means this vacuum pump does what? Pump does sucks out all of the things that are inside. So inside this glass tube there must be some air or air particles. So this vacuum pump takes out all of this air from inside. So it will become a void that we call vacuum. Okay, then we will continue our process. What we will do, we will connect the anode with the positive side of the battery and the cathode with the negative side of the battery. That means the electrons, when we will switch on, the electrons will jump from cathode to anode. As you can see, this dotted lines are all representing the flowing electrons from the cathode to anode. Okay, so also we have to remind that that this battery that we are using is a very high voltage battery that we will cover up in the experiment part. But this is the battery, and from here you can see the flow of electrons from cathode to anode is going. This particular flow of electrons is called nothing but cathode. As we can just mark over here, this particular thing is called the cathode ray. Understood? But the thing that we want to we don't knew at the time of 1897, where J.J. Thomson came and did this experiment that we are going to cover. Everything that I have told till now was not known. So what was known, that we will learn here. So what was known till that time? Dalton's model of atom. What is Dalton's model of atom? There was someone called John Dalton who first of all proposed the idea of an atom. Okay, so what is an atom? He said in his own language that he told that all of these were unknown in 1897. I have told there was only one picture of an atom. given by John Dalton, obviously. He told after breaking every matter into very small parts, ultimately we will reach to something that we cannot break further. That is called what? That is called an atom. Okay, how did it look like? It will look like a small sphere. Okay, everybody has seen, like, this is like a ball, right? This is like a plastic or a metal ball, you can see. So if the minute, in the minute scale, ultimately by breaking everything that you can see in your environment, suppose books, pencil, anything, so everything we will break, and at the end we will reach something like this. These are some small particles which he has named at his time at atoms, and after that it has been termed as atoms. Okay, so as he have told, what are the atoms? Atoms are something that are unbreakable, as I have mentioned it here. They are unbreakable. We cannot break inside the atom, as John Dalton told before 1897. Okay, there is nothing inside an atom. This was also told by John Dalton. Okay, next J.J. Thomson came and did this experiment which we are going to cover up. So let's look into the experiment quickly. So our next slide is what is cathode ray experiment. As you can see, there is a very big structure of or a circuit over here given. We will come into this one by one, but let's just read. J.J. Thomson did one experiment. He took two metal plates which are placed inside the sealed glass tube. As you can see, let me just annotate. These two glass plates are there. This is one, this is another one. Two glass plates are there. These two glass plates he have placed inside a vacuum tube. He has taken a glass tube. He had made that, and he has placed a vacuum pump. Okay, that vacuum pump will do what? It will suck out all of the air. It will suck out all of the air from inside. Okay, and it will make a vacuum inside it. Then there will be no other gas or air inside. Okay, then he connected this whole thing with a high voltage battery. It is high voltage generator. That means a high voltage battery. So then the cathode and anode are connected with a battery of very high voltage, 10 to the power 4. Okay, so it is nearly 10,000 volt, which is a large amount of voltage. Okay, usually in our household circuitry, we just use nearly 420 to 500, nearly that range. So 10,000 volt, you can just imagine, it's a very high amount of voltage he has applied to this circuit. Then one second. So this part of the plate will become very negatively charged. At that time it was not known. So what did it saw? He just wanted to see what would happen if he just connect, and there was no connection in between. Okay, here is no wire is given, na? So there is no connection in between, no wires are given. So then he just wanted to look what happens when he connects to a very high voltage. Okay, so what happened? We will see on the next slide that after switching on the high voltage battery, he saw something very unexpected. What was that unexpected thing? He saw that some mysterious rays, let me just annotate that, some mysterious rays are coming from the cathode to anode, and it was creating a green glow. Okay, that is very interesting. It was creating a green glow. As you can see, this from this cathode to anode, okay, some rays are coming. Okay, and he didn't found that what are these rays are called, and some greenish glow is seen inside the vacuum tube by the working of this cathode rays. Okay, so this was very mysterious to him also, because he have not seen anything like this previously, so he want to explain. Okay, so what he did, he tried to do some more experiments. So what he did, he just turned on the battery and see some rays are coming, and it is creating a greenish glow. Next, what he did more experiments. Obviously he need to prove what he is getting, so he had to do some more experiments which will explain what is actually going on inside, right? So he saw when he places an object inside the vacuum tube in between the cathode and anode, a shadow is being created. A shadow is being created in the background. As you can see, he has placed a suppose fan-like structure or plus-like structure, metal cross it is written. So the shadow of that metal cross is falling on the other side of the object. That means what? That means the cathode rays must move in straight line. Otherwise, how can, if it was not moving in straight line, you will not see a shadow. Now, obviously, when the sun rays are falling in straight line, you can only see your shadow. Now, if they are falling in all of the directions, they are coming from all of the directions, you cannot see a shadow. Okay, it is true for sun rays and every other ray. So he the first conclusion he did is the cathode rays, whatever it is moving in straight lines. Okay, next what he did, next he did more experiments that we will cover up. Next he did what? He did more experiments. He saw if a wheel is placed in the path of the rays, it is starting to rotate. Okay, it is rotating. That means suppose this is the very light paddled wheel. Okay, very light. Okay, lighter than the paper. Okay, so so when he placed this arrangement of wheels, okay, the cathode rays coming from this direction fall onto the wheels and started to rotate the wheels in this direction. Okay, that was very okay, that was very mysterious about this. It was not in this direction. It is in the opposite direction, right? Okay, so it was in the opposite direction that the wheels started to rotate, in this direction only. Okay, in this direction the wheel started to rotate. This was very interesting. That means the cathodes are very powerful to rotate a wheel also. That means some particles must be there, na? And only particle that can do or can come out from a substance we knew at that time was at atom, right, as given by John Dalton. So so he thought this could have been the atoms are coming out from the cathode to anode. Okay, so as you can see, but from this observation only, previous observation, he have told himself that they must be moving in straight lines. From this observation, he has told himself that, okay, this observation tells us they are very fast moving particles inside the cathode rays. There are very fast moving particles inside the cathode rays. Next, what he did? Next, he did more experiments, obviously, to find the next conclusion that he could do. So he saw if a negative and positive charge place, sorry, 1 second. He saw that if a negative and positive charged plate is placed in the tube on the two sides of the tube, as you can see in the figure over here, then what happened? Then a strange thing happened. Again, number 3 in our list. So the cathode rays are actually not moving in straight lines. Now they are deflecting towards the positive side or the positive plate. So when a particular ray or a series of particle or a ray of particle will move on the positive side, if they are obviously negatively charged, because positive sides will repel, negative sides should also repel. So negative side plate must have repelled these particles, and they have got attracted towards the positive sided plate. Okay, so that was the conclusion made by Thomson at that time, that he have told that the cathode rays must have negative charge. Okay, as it is written over here, cathode rays are negatively charged as they are moving towards the positive charge place. Obviously, opposite charge attracts. That is why. So next, what he did? Wait 1 second. Next, what he did? He found 3 conclusions. Till now, he had found 3 conclusions. So finally, he did his experiments and he had concluded that, okay, there was nothing else inside the tube, and the cathode rays must have come from the left metal plate called cathode. Obviously, there was nothing inside the cathode ray tube previously, because everything was sucked out by the vacuum tube only. So there must be, all of the rays are coming from the cathode towards the anode. Okay, that rays must have carrying some new kind of particles, because atoms, if we're moving from this left to right, if atoms were moving from left to right, then they are not negatively charged. Now they are neutral. Dalton also told that the atoms are neutral, so they should not deviate towards the positive or negative charge plate. They are deviating, so they must be not some atoms, okay, there must be some other particles. So where these other particles are coming from, because all of the matter is made out of atoms, nothing else, nothing negatively charged is there. Okay, so atoms have no charge, but cathode rays do have negative charge. This was a very big problem to John Dalton. Okay, that is why he took several days to think, and then he concluded the thing that we are going to learn, that was a new particle. Okay, till that moment it was not found. He found a new kind of particle. So these cathode rays are a stream of new particles. Okay, this is very important. New particles are coming from the cathode to anode. He named them as electrons. Okay, so these particles that we are seeing like in blue dots, these particles are nothing but they are not atom, they are very smaller than atom, and they are coming from the cathode to anode, and they are called electrons. They stay, the electrons stay inside the atom. This was obviously explained afterwards when we will go on to the plum pudding experiment. Then we will know these atoms, electrons are coming inside from the atoms. Okay, so now we will move on to the conclusion part. Okay, so summary. So to just summarize everything else, so whatever we have till now done, what cathode ray experiment was, it was done by John Dalton. What he did, he took a discharge tube. This tube is called discharge tube. He has taken this discharge tube and placed a vacuum. It will suck out all of the air inside. Then he had started the battery over here, very high voltage battery, 10,000 volts. Okay, so 10,000 volts, very high voltage battery. So he has started the battery, and he has saw some of the cathode rays or electrons. Actually, now we will call them electrons. Cathode rays, which are actually consisting of electrons, are coming out from the left hand side, from the cathode to anode, and creating a greenish glow and completing the circuit. Okay, this is very important. Completing the circuit, that means the current is flowing through the circuit. That means the circuit is completed. Although there is nothing, there is no wire inside here, but the current is flowing from the left hand side to the right hand side. As we can see, the electrons are jumping from this side to this side, not just by this, they are jumping in straight lines. Okay, they can do that, we cannot do, and that is their capability. They can jump from one side to another side. Where they did get this energy to dump, they did get this energy from the battery itself. The battery is pushing them to jump. That is why they are jumping straight from this to this. If the battery was very low voltage, then they could not jump, then we cannot see any current flow, then we could not see any cathode rays. Okay, that is why a very high voltage battery is required. So let us just conclude some things. Number one, what we have learned, cathode rays are nothing but stream of electrons, obviously. Next one is cathode rays travel in straight line. As we have seen, it was creating a shadow over here. As we are placing something, there was a shadow created over here. Okay, that means they move in straight line. Number one, two is done. Number three is cathode rays consist of very fast moving particles. Obviously, they were moving the fan that we have created now. That fan was also moving by the electrons are heating the blades of the fan. As if you just heat the blade of your fan in your household, if it is not moving, obviously, so it will move now. That means you are giving a push. The electrons are obviously pushing the fan itself. That is why the fan was moving. So number one done, number two done, number three, electrons are very fast moving particles. Number four says cathode rays are negatively charged. As they were moving towards, they will move towards the positive side. If I place a positive sided something, a positive charge something, they will move towards, they will not go straight, they will move towards the positive side of the plate. That is why they are negatively charged. Obviously the opposite sides attract, that is why. Understood? So four conclusions we have made, okay, from here. So as we have done this cathode ray experiment, this was the end of my lecture. As we have, I think all of the students have learned something new about the cathode ray experiment. It was a great experiment where J.J. Thomson actually discovered a new particle called the cathode rays, and actually new particles were called electrons, which were inside the cathode rays. And later on, he explained how this was inside the atom actually. Okay, that we will discuss in the next class. Okay, goodbye.